Hey everybody, we are here with another exam review problem for physics. So in this case we have Mr. Hartigan. This is number 6, by the way. Also, this problem is marked E and H, which means it is relevant for all 3 versions of the exam. Being able to do this will help you be prepared for any of the 3 versions of the exam. So here we have Mr. Hartigan is going for a pleasant Sunday drive, coasting at a relaxing 20 meters per second, when suddenly a family of birds flies into the road and refuses to move. He spends the next 2.5 seconds applying the brakes, reducing his speed to a measly 5 meters per second before the birds fly away. What was his acceleration during this time? Okay, here we go. We have the road, here's the car. All my cars have smiley faces, don't worry about it. So we have our initial and our final point here. We have Mr. Hartigan driving in his car. He's coasting at a relaxing 20 meters per second before slamming on the brakes. So before the acceleration's applied, he's moving at a speed of 20 meters per second. So we could say that this is our initial velocity is 20. So let's see, 20 meters per second is going to be our initial velocity. Birds are going to the road, refuse to move. I'm going to call the structure positive, by the way. Mr. Hartigan spends 2.5 seconds, so 2.5 seconds is going to be a time, obviously. Trying to apply the brakes, reducing his speed to a measly 5 before they fly away. So his speed goes to a speed of 5 meters per second squared. Sorry, meters per second, pardon me. So he starts at 20, moves to 5, meaning at the end of this time period, after he applies the acceleration, his final velocity is 5. And we want to find his acceleration during this time. So we can say, then, let's go ahead and gather our variables. We have xi, we have xf for initial and final position. We have vi, we have vf for initial and final velocity. We have a for acceleration and t for time. So, our initial position we can always call 0. We start here, we measure from here. Our final position, we actually don't know how long this distance is, right? The problem doesn't tell us how far away he moves or over what distance he moves. So we're going to actually go ahead and cross this out. Our initial velocity, like we said, was 20. Right, that's how fast he's moving before hitting the brakes. His final velocity after hitting the brakes is 5. So we want to know his acceleration. The problem is asking for that. What was his acceleration? And the time that's spent is 2.5 seconds. So now we can move on and pick our equation. We are missing xf. We have the rest. So we're missing xf according to our equation sheet. When we're missing xf, we use the first kinematic equation, which is vf equals vi plus a times t. Now we can put all of our numbers over here into here, and hopefully that'll make this feel a little better. So vf is 5, vi is 20, acceleration is, we'll leave as an a, and time is 2.5. So we have 5 equals 20 plus 2.5a. We want to get 2.5a by itself. We can subtract both sides, subtract 20 from both sides. So we get negative 15 equals 2.5 times a. Divide both sides of this by 2.5, and we get a equals, I believe, negative 6, if I do this in my head correctly. Let's see how we did. Yep, negative 6 meters per second squared. And it should make sense that our acceleration is negative because we're braking, right? He's moving this direction. Moving in this direction, and he's braking. So he's slowing down, meaning the acceleration points the opposite direction. So makes sense that our acceleration here should be negative. Hopefully you guys didn't find this one too bad. I'll see you for the next one.